Thank you again for your time and a very warm welcome to our webinar, which offers a tester lecture for the MSc in Major Program Management. My name is Anastasia Dijken, and I'm a Business Development Executive here at Said Business School. This webinar is particularly well timed as we are approaching an important application deadline on the 2nd of June. You may be here today because you have either new or long-standing interest in the program. You might also have already spoken with my colleague Joe, the recruitment manager for the program, or with me directly. So the purpose of today's session is to give you a feel for the program through a tester lecture, and we are delighted to be joined by the program's academic director, Professor Daniel Armanios, who will explore the latest advancements in AI and their likely impact on major projects and programs. So without further ado, Daniel, over to you.
Thank you, Anastasia. It's always a pleasure to be with you and pleasure to be with all your faces, some of which I actually recognize, which is great. Let me go ahead and share my screen here. Can everyone see my screen? Yes, no, maybe so. Let me make sure I have perfect. Let me get the chat on. So if you have any questions, I can try to answer them as best I can. Bear with me here. Going to put on the chat. Here we go. Oh, it's here. Magic. Chat. Excellent. Yes, yes, yes. Great. And then we can do this. Perfect. Now we're set. Okay. So I'm going to be talking about some of the cutting edge work we've done around AI major programs. There's a second half to this, which I won't get into, is we've actually created probably the first of its kind framework for how to deploy AI in project and organization settings that's been piloted and such around here in Oxford as well as elsewhere. So kind of what are major programs? Let me just start with kind of the basics first. There is a kind of academic view, which is essentially very large scale initiatives, usually portfolios of projects that are connected together that have a lot of complexity due to the stakeholders involved, and also because what goes into them, how long it takes, and what goes out is all unclear and ambiguous. It's probably some of you, this is very usual for your workplace, but for others, this may be somewhere you're aspiring to go. In terms of a practitioner view, usually you're talking about projects over £1 billion. People can debate this. IT projects are quite complex as major programs don't necessarily reach 1 billion. In fact, million people take 5+ years to build. Why this is important is because when you start a project, often the program manager that starts it may not be there at the end. So you have to start thinking about the institutional aspects. So if I ask you before you went to this lecture, kind of what comes to mind when you think of a major program, does anybody in the chat want to share what comes to mind for them? Maybe you could put in some thoughts in the chat of what you immediately think of when it comes to mind to you. HS2, Olympics, some transformation programs, digital ones, very good. I see wider examples than usual, which is great. Ober, someone will have to tell me what OBOR is that you're mentioning here, or maybe it's a typo. Yeah, Saudi Arabia, the vision, oil and gas projects, complex scalability. Yep, finance. Yeah, very good. I would say that airports, big infrastructure, very good. I would say that historically, especially the theories, are around what most of you mentioned. Some are mentioning other places, which is kind of like stadiums. So the Olympics, someone mentioned, infrastructure, refinery upgrades, sustainable development goals could be one around the infrastructure. So usually this is where our theories are. But what I really love about your examples is that they go wider than that, right? And this is becoming really, really important around issues of AI. So usually, just to be clear, theoretically, we think in mega projects, big infrastructure projects, but increasingly what you all are mentioning is the emerging reality, which often is going to play a role with AI in terms of the distributed nature of programs. So let me give you some examples that are happening right now in AI that the future, we often say the future is here and now is unevenly distributed. So this is the first one around China. So let me start here. The Chinese have built the Yangtze Dam. They're currently building its 590-foot dam. It's being built with the largest 3D printer, in the world. And they're also, with the exception of just the mining, everything is run by autonomous vehicles and AI. So the only thing that's actually human is the mining of the project. So everything else is automated. The one you see on the bottom here, sorry for the automation, I'm not sure why it's doing that, but on the bottom is this 3D printed train station in Japan. This happened last month. It was printed in 6 hours overnight. This usually would take about 2 to 3 months. So they use an AI guided 3D printer to print this machine. Some of you may have heard of Manus. This is Manus in action. So Manus here is actually running 50 different social media platforms at once. It's a multi-agent model that's literally running with LLMs and agents, AI models. And this can do really powerful things. Essentially, it can do all the automation that you do with code and ChatGPT, but now have automated agents run it, which is pretty remarkable. So why did I bring these up? Yes, if anyone comes up afterwards, I will share a PDF with the organizers, and you're more than welcome to click through the links. So what's happening is the mega projects I brought up before often are multi-organizational, but they tend to focus on a single site. While right now with AI, you can have AI, edge computing, other things run kind of autonomously quite far away from certain single sites. There's multiple sites, all have to be governed in different ways. Even infrastructure is going this way with modular infrastructure construction, different recycling and policy programs, for example. The previous idea was to take one thing and make it bigger. Now we're talking about right sizing, which is essentially taking things and catering it to different demand in different municipalities. One, we talk about replicating ends. Now we're talking about replicating means because the ends may be different depending on where you are in the world. So you're dealing with something that's no longer standardized, but quite situated. So this is where the theory is right now. What we're preparing you for and where our frameworks and things we're speaking to is more this emerging reality. So we're really known in Oxford being globally in terms of finding, globally, we're known for really bringing the cutting edge into this space. So to level set when we talk about AI is not just one thing, okay? It's multiple things. AI is essentially the tools you use to apply machine learning, okay? It can be generative AI, it can be natural language processing, it can be computer vision, it can be even regressions. So it's not just one thing. And also to understand this science, there's kind of three things, just to start with a common language. So if we're talking about the science of AI, which is machine learning, we think about it in kind of three ways. One is supervised learning. That's using labeled data for which you know what you're looking for and you're trying to build associations. Think of a regression, right? I have an outcome variable. I run a trend through a bunch of different dimensions and I get a trend. Unsupervised learning is the exact opposite. I have unlabeled data, essentially data that has some characteristics, but I don't know which labels matter, right? So this is like clustering, for example, where you try to have dimensions that are internally consistent but far apart from each of the other clusters. And then finally, reinforcement learning, essentially having agents do this. So you have agents in an environment with some policy rules, they make some actions, and then we give them feedback saying, yes, this is good, which is a reward, this is not good as a penalty. And this is Q learning, for example. And to give you kind of a visual, you can kind of see it this way, that supervised is based on classification regression. You can kind of see unsupervised, trying to find the dimensions that matter. So what I'm going to try to get at with this is try to tell you the emerging gaps in major programs, as well as some weird paradoxes that have been happening. We'll start with the major program itself, and we'll talk within that the skills gap. So what we're happening with AI is that more and more of you are probably asked to use AI, but there's far fewer at the cutting edge of its development. So there's a big gap between users and developers. The effort gap, it's really, really easy to produce stuff now. But a lot of that is not very useful. So it's a lot more time in being able to detect what's useful or not. And that's a big issue. On the other side, there's this weird paradox whereby we're tending to increasingly trust the outputs of AI, even though we know the inputs are biased, right? So this is kind of an interesting paradox that's emerging. If we go down the level in terms of the infrastructure, what's powering the kind of AI tools in your program, we get one with a massive computing gap. So there's a lot of ability to process a bunch of information, but the resources available energy-wise, environmentally, are ever becoming limited. There's also an access paradox. There's a lot more reach of these kind of tools, but it's actually not concentrated. It's not distributed evenly. It's concentrated in the hands of a few. So let's start with the program. So if we think of any kind of major program, you're usually thinking of the strategy. What's the overall objective I want to achieve? There's a layer of management trying to get you to get these things done, and then you're executing the tasks. Does anyone want to say what happens to uncertainty as you go down? So as you get down to the routines, what in theory should happen to uncertainty? Should it increase or decrease? Anyone want to take a guess? At least in your own world? Yeah, it should, Henny, that's very good. Should decrease, right? The idea is that you make it easier to do the work by filtering out uncertainty. Now, here's the problem, okay? Where are we putting AI? We're usually putting AI here. And in fact, you can see in this table, it's saying where the highest commercial value is, and I'll put some ink here. The highest commercial value is here, right? It's actually on supervised learning. So what's the challenge is you're adding in uncertainty from AI precisely in the parts of the program that are not equipped to understand how to handle it. And this is a fundamental challenge, right? So it becomes even worse when the kinds of tools are built by people that are not in that space, right? So this is a plot from Statista before ChatGPT about where they thought usage of the AI tools would come. It was already about 730 million. If you look at GitHub, which is one of the biggest development sites, and by the way, not every developer on GitHub is doing AI. Even then, if you take just that as a very coarse estimate, you're only looking at about 94 million developers. So you have 730 million people asked to use it and only 94 million developers. So we don't have all the users, quite a few users are not in places of development or on the developing edge. Can think of the same thing with production. So just to tell you how this is advanced, I'll show you a couple of videos so you can get a sense. So this was in 2023 with Studio DID. So I took a selfie. I went on ChatGPT and asked, make a 1-minute speech that Daniel Armanios would say about major programs. I recorded the voiceover, and then this software stitched the thing together. It took me about 15 minutes. It was free, and you can get a subscription if you want at the time. And here's what it looked like. This was the early days of this.
Good afternoon, everyone.
Can you all hear that?
I'm honored to be here today to talk to you about the importance of major programs in driving change and achieving objectives. As executives, you are often faced with complex challenges that require a coordinated and collaborative effort to address. Major programs are a key tool for addressing these challenges, as they bring together multiple stakeholders and resources to achieve a common goal. However, delivering a successful major program requires more than just assembling a team and a plan. It requires a clear understanding of objectives, a well-defined governance structure, and a structured approach to managing risks and change. It is also essential to engage with stakeholders and ensure that their needs and expectations are taken into consideration. Throughout the program, this requires effective communication, collaboration, and the ability to build relationships and trust. So as leaders, it is important to understand the key principles of major program management and to develop the skills and knowledge needed to lead and manage these complex initiatives effectively. In conclusion, major programs are a critical tool for driving change and achieving objectives. By developing a deep understanding of the key principles of major program management, you will be better equipped to lead and manage these initiatives successfully. Thank you.
So this is considered ancient technology in AI world, which is still pretty remarkable. And by the way, thank you, Anastasia, for putting all the links. That way we're going to have them immediately now. This is considered ancient technology, about 2023. I want to show you what's happening now. So this is what we did at our last major program conference. I actually built an avatar. So again, the last video was fake. This is also fake. This is actually an avatar I created for our conference last year, and you could see how quickly the advancement have happened in the year. This is in still beta version. It's one of the more high advancements, HeyGen, and it's heygen.com. You can find it, but I give you a little taste of what that's doing. And this is just a large language model backend that I kind of promoted of how to work, and it automatically drives this.
Hey, Judy. We're actually talking in front of the audience at the 2024 Oxford Major Program Management Conference. Do you want to say hi to everyone?
Hey there. Hi, everyone at the Oxford Major Program Management Conference. I'm excited to be here and ready to help with your big projects. What major program are you all focusing on today?
Well, actually, the topic of our talk right now is the path forward, or the future of major programs. What do you think are the most exciting trends in the future of major programs?
That sounds fascinating. Some exciting trends include increased use of AI and data analytics for decision-making, agile methodologies in large programs, and a stronger focus on sustainability and stakeholder engagement. What specific trends are you most interested in exploring?
Judy, if you wanted to tell our audience what is the one most important trend in AI, one most important trend in sustainability, and one most important trend in stakeholder management, what would you tell our audience today?
Absolutely. For AI, I'd highlight predictive analytics, which helps in forecasting project outcomes. In sustainability, integrated project delivery that prioritizes eco-friendly practices is key. For stakeholder management, transparent communication and collaboration platforms are essential for building trust. What do you think?
Yeah, I agree with you. If you had to pick the one tool that major program management professionals should look at for AI, sustainability, and stakeholder management, which one would you pick?
Great question. For AI, I'd recommend predictive analytics software like Tableau for insights. For sustainability, a tool like EcoTracker can help monitor environmental impact. For stakeholder management, a platform like Trello can enhance collaboration and engagement. Which of these resonates most with your audience?
They all seem great, but unfortunately, we have to head out. I can't talk for too long with you. Is there any final words you want to tell our audience?
Of course. Remember, the success of major programs relies on collaboration, adaptability, and continuous learning. Embrace innovation, keep your stakeholders engaged, and aim for sustainability. Good luck, everyone.
Thanks so much, Judy. That was a fun chat, and I'm looking forward to brainstorming further in the future. Take care.
You're welcome. I'm glad you enjoyed it. Looking forward to brainstorming more together. Take care and best of luck with your projects.
So you can see it's getting quite advanced, and there's even now agents that can replicate you in meetings. People don't even know, and even the beta version is about 60% accurate. So it's pretty remarkable what's happening in this space. Now, what is happening? Why is this important for you? Let's take a very simple example before I get into simplicity, complexity, tension. Let me say I go on generative AI, DALL-E, make an image of a receipt, ask it to be crumpled, tell it to put a restaurant number and a credit card number. You can find actually an image that if you then sent it to your expense payment systems, you could likely get it expensed. And if you think of the projects that are coming out, some of them quite fabricated, these are rigging our current systems, and we're not very good at dealing with it. And this is why what's happening. So on one hand, let's say I have two data points, and I want to find the closest, most accurate connection between them. The simplest way is a line, right? Now, you don't get much accuracy from it, but if some weird other data comes in that's adversarial or trying to rig you, you can see it, and it's harder to hide. What LLMs are doing is something like this. It's a bunch of hidden layers and networks, etc. So if I run the same kind of model, I get really good accuracy, but it's much easier to hide. See the black dot here? It's much harder to see. And that's essentially the idea. It's less realistic, harder to hide. The other one's more realistic, but easier to hide, right? And so, as I mentioned, the image of this is an example of a crumpled image receipt that you could do in Gen AI. Add a credit card number, you can get it through. I'm giving you this example that this is actually happening now. There's a case that's being litigated the last year in the United States where a major program was developed that that actually rigs Spotify's trackers. So usually Spotify, if you get way too many counts in the beginning, it'll trigger kind of a check or a scrutiny. But if you have 1,000 views over 1,000 accounts, it won't. So what they did was they created 1,000 fake songs, 1,000 fake accounts, and just had them each do it 1,000 times. It defrauded Spotify of $10 million. It was literally a major program of fraud. And why I'm sending you this link is that it's going to be interesting when the lawyers bring up the forensic evidence, how they were able to detect it, because this is going to be very much a cat and mouse game. So now let's look at a paradox. So I'm going to give you, this is currently available in the United States. It's text to video. And I want you to look at these videos and I want you to tell me which ones are Sora, which are fake, and which ones are PowerPoint stock, which are real. And so let's start with the first one. How many of you want to say this is Sora or PowerPoint, which is real? You can put your answers in the chat. Yep, very good. This is Sora. This is one of their platforms. You could tell some of the letters in the background aren't the case. How about this one, the second one? Is that Sora or PowerPoint? So some are saying real. Yep, this is real. Now we're going to start getting a bit trickier. How about this one? Is that Sora or is that PowerPoint? I'm saying Sora. AI. Yep. So this one, some now people are getting confused. This one, if you look at the fluid mechanics of the air, you'll see it's not quite there. How about this one? Is that PowerPoint or Sora? Yeah, not sure. Now we're getting a mix. Yeah, so this one's real. How about this one? All of you are saying Sora. This is real, actually. So number 5 is real. How about this one? The chameleon is Sora, and you could tell because if you look at the back legs, they're not exactly fully formed. So that's a way to kind of learn that. So next one. How about this one? Is that Sora or real? The mix. So this is Sora doing a rendition of a Western movie scene. So that's actually Sora. How about this one? Final one. Is this real or Sora? Yep. Most are saying Sora. This is the most latest of Sora. So this is Sora, the last one. So you can tell in most classes I've done, I haven't had any in live get more than 50% right. So now why is this interesting? Is that now it's one thing if we can't tell real or truth. Now what's really even more fascinating is we're actually tending to trust AI output more. So the irony is that because of the biases of input data, we're really, really good at mirroring usually male whiter faces. And you see that here in terms of the difficulty people have in terms of most people would say something is synthetic is actually, sorry, most people think is real on the bottom is actually synthetic and so on. Now that's, we know. But what's interesting is if you look at synthetic faces versus real and ask who you trust more, people actually trust synthetic faces more, even though we know it's biased. So for example, in the top row, you see various views and we can see some gender and obviously racial biases here, but people tend to trust synthetic faces more than real. Now, this is even in social activity. There is a new set of environments that looked around social activity, and they actually looked at kind of different kinds of people running things with AI versus humans. They have AI users and human. And when they asked people who they trusted more, human users trusted the AI-driven avatars on the platform more than the human ones. They can even use AI to simulate social interactions. This was a party that was developed simply driven entirely by AI agents. And we know we question this because if we look at studies of the biases, we know, for example, even as much as 2018, if we take a highlighter here, that for female darker faces, it's almost a coin flip as to whether it gets it right or wrong in terms of accuracy. So we know the inputs are problematic. And even people have been wrongly accused. Sorry, whoops. Let me put this back on. Apologies. Can everyone see my screen or do I need to share again? Yeah, can you see my screen? Okay, all good, perfect. So, Robert Williams is one of a person that was wrongly accused of a crime that didn't simply by AI recognition. So the issue here is that we're introducing uncertainty precisely in the parts of organization least equipped to handle it. And if we can barely understand real or not, and we're experts in programs, imagine what frontline workers are seeing. So one way to think about this is bifurcating your uncertainty. So I think AI is best understood through selection and processing algorithms. Instead of supervised, unsupervised, the more important organizational aspect is selection-based algorithms, which gives you an attached probability as to what is real or not, think spam or phishing. And the other one's processing, which is using the data I have available to make decisions through trends. But I want to make sure I have real data. So instead of just absorbing uncertainty, we bifurcate it, meaning we put in a selection algorithm to kind of filter out information that may not be good. And then from that, we can then use what we think is more reliable real data to process. And so you get a sense here of what I mean by uncertainty bifurcation. It's splitting the detection of false information and then the reading and patterns of trends to improve work based on what we think is more confident in being real. We can now think of scaffolding. How do we deal with the fact that we have trouble looking at the difference? Maybe we could think of a nutrition label for AI. So for example, how representative is the data? So for example, if you use a hiring algorithm in a company where they're mainly male, then obviously what the algorithm is going to recommend is male hires, right? And vice versa, if you're a fundamental female company and you have a hiring algorithm that's more female, it's going to hire more female, right? Dependability, these algorithms change their answer all the time, right? Every 1 year, every 2 years, even a few months. If you, for example, if you want to test this for yourself, if you give the same question to ChatGPT today versus tomorrow, you're going to get different answers because it's updating its learning over each day, right? Vulnerability, where can it be attacked? So that I have to be aware of. So we could think of maybe representativeness. The input data was, in this case, something is 70% Hispanic versus 30% white, and it changes it, which means maybe it's more biased towards understanding what to do around those who identify as white. Dependability, 2% change in outcomes. It's most accurate for employment, maybe because employment is more stable. And then GAN is general adversarial networks, any kind of adversarial attack, or it's vulnerable to overfitting, because if I overfit to a hiring model, then I may miss very good people that are assumed to be noise, but are not. Some are even arguing for prescription labels, kind of approved usage, potential side effects, precautions as another way to do this, right? So let's go into the infrastructure aspects in our last few minutes together. So when we often think of infrastructure, we often think of what the users of it will use and not necessarily those who are connected in unintended ways. So when I define infrastructure, to be clear, I think of intended and unintended connectivity. When I usually think of infrastructure, I'm thinking about the users. Those are going to connect to new information, connect to work, and so on. That is the intended conduit, that I go from A to B, that I access information and do things better. But what we don't often think about are those unintended bystanders that get harmed. So for example, when building the Cross Bronx Expressway, this is in New York, this is what it was before. 1,500 families were displaced to actually make that highway possible. This is in Oxford. There used to be a wall separating the low-income and high-income parts of town. And even after the wall was done, this was so entrenched that they still only paved the road up to 2018 on the more wealthier side of the neighborhood. You see this in Berlin. You can literally, as of 2012, still see the difference in lighting from the East Berlin side that uses more halogen, sodium kind of lighting versus fluorescence on West Berlin. You still see this. This was the Berlin Wall fell in 1989. This is a satellite image from 2012. Okay. So why do I say this is we have to think about the same thing here with energy use and water with AI. Just with ChatGPT 3.54, a Yale study cites this International Energy Agency report saying that the amount of servers that would be needed to reach the capacity of what we would need to power AI is roughly the equivalent of the entire consumption of Japan. In terms of water usage, 20% more usage of water than Microsoft. And even, sorry, Microsoft also 34%. So more water use, mainly in withdrawal, but there's still also evaporation. And because of where these servers are placed, they're now competing with communities for water access. So you also see protests. And to give you a sense of the water use, in terms of withdrawal, just for ChatGPT, I think it was 3, it would require half the entire consumption of the United Kingdom. Now that's the withdrawal. In terms of evaporated, it's still about, let's say, 10% of the water that's actually withdrawn is evaporated, about 0.38 to 0.66 billion cubic meters. This is non-trivial amounts of energy and data. And you see this because what's happening is a lot of these companies are now investing in small modular reactors, fusion energy, making microgrids like Westinghouse to power this stuff. To bring it more home to you, if you use like a typical prompt engineering on the side here on the left-hand side text classification, it's low. But on the very right, that gray one is doing a generative AI image. I want you to take out your phone for a moment and ask yourself how worth it is for you to create a generative AI image. Right now, to create a generative AI image, just one is equivalent to charging your smartphone 50%. Okay, so just to give you a sense of the amount of the energy we're talking about here. One new generative AI image is equivalent to charging your smartphone 50%. They did this for 1,000 images. That's why you get 522, about 50%. So at one side, the tension is we're getting massive reach, massive kind of trends in terms of access, and we're able to produce at unprecedented levels. On the other hand, we're really straining our resources. So this I love this pace from 2000, because this was the projection scarcity in 2025 in terms of water with population change. We're really at a point where we're stressing an already scarce resource. On the other hand, if you think of reach, again, many people using it. But if you look at, for example, Bitcoin, only 64 agents are mining most of the Bitcoin, and you see quite a bit of kind of server farms that are doing this, and they could technically do attacks that would allow them to take it all, but because they're cooperative, as of now, you're not seeing that. So you have a lot of reach, everybody's accessing it, but few have hold of the resources. And this has generated huge tensions between the Nordic countries, Scandinavia, and China, because of the fact that the Chinese have been moving a lot of their servers where cheap electricity is, namely hydroelectricity, to mine Bitcoin. So one thing we may have to think about is maybe we need to penalize our algorithms to be more parsimonious, but also to look at things we can't see. So for example, in this smart traffic system here, notice they're all cars. In the way in the back, there's one bus. And we assume that what these algorithms assume is, oh, this might be a road that buses don't want to be on. The problem is with that is that assumes that everyone can access all the roads equally. But if there's a bridge that's restricting buses 5 miles down, it doesn't see that. And so even our physical location can bias our data. So one thing we've been thinking about is, why don't we run models with smaller data? Why does AI need to be with big data? It doesn't. It could be with small data, especially if you have really strong specialist data. We see this with Bitcoin and Ethereum. Bitcoin, instead of doing proof of work, which is mining based on a complex math problem, Ethereum gives coins based on proof of stake, which is only randomly selecting people to validate coinage. It doesn't deal with the equity issue, but it does deal with energy. And we've also developed some work using some very basic models that are kind of under revision right now in journals, just looking at 2 parameters instead of billions. The final thing I'll tell you is, perhaps instead of assuming that our programs are proxies of access, maybe we should just be honest with ourselves and proxies of bias or something we've missed. And so we used COVID to help us understand this, and this will be the final points I make, is that during COVID, one of the key issues was you now needed broadband. It became an essential infrastructure. Typically, it's water, housing, etc. But right now, it's infrastructure in terms of broadband access became crucial because we had to stay at home. And now a lot of people are in stress to get access to infrastructure. And so we said, perhaps could we use broadband in its gaps to detect where people could use help during COVID? Now, where we came with this, how we came to this idea of that maybe it's not access but bias, is from this graph. We had assumed that when we have more broadband, we would have less unemployment. So we'd assumed the black line would go under the red line, but it didn't, it went more. So the question is, why did this happen? It's how we measure broadband. So the issue is that when you measure broadband spatially, let's say it's 80%. Let's say we have 10 houses here and I have 80%. What this assumes is that every 10 households see at least 2 that are not getting access. So everyone sees someone who doesn't have access and they're aware of it. But we know that access is unevenly distributed, meaning what's more likely happening is if I have 100 neighborhoods, 80 of them have 100% access and 20 may have none. And no one sees that, even if it's next to them. And so the challenge becomes, maybe we're assuming people have access to broadband that don't, and that's becoming an issue in terms of handling COVID. And we see this in several counties. The lighter shades are those who have less access. Notice that the ones that are higher unemployment below have much more concentrated in access. Fewer people see those who don't have access, versus above where there's a bit more unemployment, but less so, there's much more distributed recognition of inaccess. So perhaps if we look at the gaps of where our programs are not, that can help us address this reach inequity divide. So to kind of summarize, we talked about major programs. We talked about the tensions between users and developers. It's specifically around the fact that we're putting uncertainty in places where in our program historically had a lot of certainty. So now you have to think of the skills gap. You have to think about it's really easy to produce information, but not really easy to detect its value or even if it's fabricated. And we have to deal with this weird trust paradox, which is that we tend to buy in the outputs even though we know the inputs shouldn't be trusted. And then we have to think about powering these things upstream. We're using a lot of power to develop these ideas. And at the same time, we don't have as much resources to hold that, even if we paid more for it. And at the same time, we're getting more reach. It's not necessarily equitable. We thought of some different solutions. Scaffolding help explain, translate what the algorithms actually do in words that are comprehensible beyond developers, so people use it more appropriately. We talked about bifurcating uncertainty. So you you try to remove fabricated information at the top of the program where people are more familiar with ambiguity and can tell when things are snake oil versus not, before you then take the data and process it in ways that are easier for frontline workers to understand. Parsimony, you don't need big data for everything. You don't need billions of parameters for everything. We need to be smarter about where we use our algorithms and our technologies. And finally, perhaps we should think about where our programs are not going to help us understand where we should be doing future programs that should be going. And with that, it was wonderful to chat with y'all. Please do reach out. Let me know if I can be of help with anything. And I'm happy to talk further if anything else as well. Thank you so much.
Thank you, Daniel, for taking us on this journey through emerging gaps and paradoxes with you. I'm sure it has been really insightful for everyone joining us today. Just before we finish, I would like to take a few minutes to cover the application process for the program. I'll quickly share my slides. Can everyone see my slides? Lovely. Right. As a reminder, our next application deadline is 2nd of June. Please note that places may not be available after this date, as in recent years we have operated waiting lists due to high demand. I therefore would encourage you to submit your application before 2nd of June if you're interested in joining the program this year. Our MSc in Major Program Management is a 2-year part-time program. Oh, sorry, wrong slide. I'm so sorry. It's a 2-year part-time program delivered by Said Business School at University of Oxford. The next start date is October 2025. This is a part-time program, which means that most students will be working alongside completing this course. The 2 years comprise 8 in-person modules, each 5 days long, delivered on campus. And then there are 40 hours before and 40 hours after the module of self-guided study and assessments. In terms of entry requirements, we are looking for a minimum of 7 years of relevant professional experience, as the program is designed for people with existing program management experience. Another requirement is to have an undergraduate degree or equivalent professional qualification. We also consider applicants without such qualifications who can demonstrate a particularly strong employment record and/or hold certain professional qualifications. And finally, the program fee for 2025, as mentioned on the slide. And some final points on how to submit an application. As already mentioned, we are looking for at least 7 years of professional experience and an undergraduate degree. We are also looking for an English language proficiency, either via a test that you've completed or significant work experience in English. You'll be pleased to hear there is no GMAT or GRE requirements for this course. You'll only have to submit an up-to-date CV, academic transcripts, nominate 2 people to provide professional references, and write 3 essays. And just a kind of reminder again about the upcoming application deadlines. Again, I would encourage you to submit an application before our next deadline on 2nd of June. And of course, if you have any questions about the program or the application process that we haven't covered here today, please get in touch with me or my colleague Joe, and we will be happy to support you. You can see our email addresses here on the slide. Thank you everyone for joining us today. Thank you, Daniel, for this insightful lecture. We hope that this webinar was really insightful and gave you a better understanding of the program. And I honestly hope to see you soon on our other events or hopefully in the classroom in October. Thank you so much and have a lovely day, everyone.